Hello and welcome to our webinar, BIOVIA and Discngine, Automating Assay Analytics, presented today by Thomas Blar, PhD in Computational Chemistry and Software Scientist at Discngine, and Guillaume Payard, Science Cloud Advisory Solution Scientist, Lead Customer Project Management at Dassault Systèmes BIOVIA. My name is Michael Gans, Senior Program Manager at Dassault Systèmes, and I'll be moderating this session. Before we begin, I'd like to note that attendee phone lines are muted. If you have any questions during the webinar, please submit them at any time via the questions or chat windows in the GoToWebinar control panel, and we'll answer them at the end of the session. And now I'd like to turn the webinar over to Guillaume to begin today's presentation. Guillaume, it's all yours.
Thank you, Michael. Thanks everyone for joining this webinar. So today will be about plate data analytics, and more specifically, how you can get your plate data saved on a platter thanks to Assay Autopilot. So during this webinar, we'll be, first of all, we'll be looking into some current plate data analytics challenges and see how the system can help on those challenges. Then I will invite my colleague Thomas to join us and talk about some specific use case on the matter that he has addressed with our solutions. And we got a discussions around the different advantages bring by that solutions. We'll have with some summary and open up the floor to a Q&A session. So plate data analytics today has been changing since the beginning, and it's continuing to changing, and basically everything is growing right now. So there's a lot of different aspects that are changing. There is more and more instrument types, new ones just coming up to the market very quickly, bringing new way of looking at looking for scientific informations, new type of assay as well. I mean, starting from the first days, where moving from low throughput up to high throughput screening, from simple throughput screening, single point dose response to HS and so on, and now even far more complicated type of assay. The volume of data is also growing accordingly with the capacity of the instruments and of the assays to produce those kind of data. If the simplest example coming to your mind, obviously, is if you just compare the amount of data produced by an HTS screening versus what was produced at the time by HTS. With that level of complexity also comes complexity in the way you want to analyze the data. It's not just about doing some deduction, some simple normalizations. You want to be able to apply more complex data analysis on the raw data to get access to the final end result. And there's also other aspects coming into play in the way those plate data analytics experiments are performed. Nowadays it's all about collaborations, competitions, M&As. So it's not just your organizations doing all the work. It's probably working with other organizations that has other capabilities and other ways of looking at the data. Along with those changes, there's just other challenges very common to the whole industry that are coming into play, which you can summarize by first a need to reduce the discovery time with flexible and integrated solutions. So it's about being able to react to those changes I just described, to that growth in the way the different type of assay, the different instruments, and so on. How to adopt them quickly and efficiently to keep the innovation edge in the industry. Also, it's about completing the workflow more efficiently and reliably in cheminformatic and bioinformatic discovery process. There is a need for not only for the people producing the data, but for the people consuming those data to be able to trust and rely on those data, and so to trust the way they're produced efficiently and in a reproducible manner. So before going any further, I'd like to ask first questions to the audience. Michael?
Very good. Yep. So the audience should see on their screen now our first poll question. What has the most impact on your ability to quickly adapt and extend your plate data analytics workflows? And feel free to select the option, growing number of instrument types, growing number of assay types, volume of data, and increase in complexity of the assay results analysis. And so I'm sharing the results of the poll. We have 8% saying growing number of instrument types, 8% also saying growing number of assay types. 38% of people have said volume of data, and 46% have said increase in complexity of the assay results analysis. So Guillaume, does that have any impact on you, or do you have any thoughts on that?
Well, as a matter of fact, it resonates pretty well to the next point I wanted to make. So we just talked about those challenges, both in data analytics and in the industry itself. But now, people are obviously looking for solutions. And if you just look at some of the trend analysis, the one from Gartner, for example, here, that Gartner just made this year about strategic technology, one of the key ones that comes is augmented analytics. So to redefine slightly what they have in mind by that is about the ability to automate your analysis process, and also to bring in quickly and efficiently new way of analyzing your data. So that's pretty much resonate with that large part of the goal, being mainly cornered by the fact that the difficulty of analyzing the data is ever growing. So according to Gartner, 40% of the data produced by science tasks will be automated in 2020. So that's great, we get this big trend, but what does that mean exactly what are the expected benefits? What could be the expected benefits for plain data analytics? Well, first of all, it's keeping up with the amount of data, which was, if I remember well, Michael, that was the second one in the of the main problem in the audience. So keeping up with the amount of data, new and legacy. New ones because there is more and more produced every day, but the legacy one also because you may want to have a way to look back on your data, the one that was produced in the past, in a way that is comparable to the new one. It's about reducing errors as well. With the ever-growing amount of data, with the complexity in the analysis, well, not saying that computers are better than humans, but, well, we're all humans, so we know we're making mistakes. We need to ensure that the way we produce new information that will be critical in the decision we will make in our scientific project is, as much error-free as possible. It's also about standardizing your data. We'll come back around this during our discussion, most probably, but to have data produced consistently within the same, with comparable definitions, ontology, and the like, being really able to compare apple with apple is very important, not only in the quite classical way of making decisions, but it's also important when you take it back on new trends, for example, machine learning and other similar kind of topics. And finally, there is a need on focus. The promise that augmented analytics is bringing is the ability for the scientists to focus on science and on their business problems, rather than focusing on, I would say, the more trivial and technical aspect of the analysis itself. So it's more about thinking how you want to do the analysis, being able to make those scientific decisions on how you process the data, apply them easily, and get the results easily as well. So before going further into how we will address those challenges and provide some solution in that direction, let's talk first about the solutions the data system and BIOVIA is providing in collaboration with Discngine, which is called BIOVIA Assay, which is our solutions to analyze your plate-based assays from raw data to result storage. So it's all about processing the data produced by plate-based assays. So a good way to summarize BIOVIA Assay is this schematic I'm displaying right now, where basically starting from virtually any kind of instruments or any kind of assay, you can see in the upper right the different kind of assay that we are addressing with Assay. The one in plain black are the one that are configured out of the box. The one in gray are the one that, with the X-axis system, with additional configuration, those are some examples of more asset type that we have been addressing for our customers. And so with Assay, you'll be able to really set up all the chain of all the steps necessary to process your data from raw data up to the final result. So it's about being able to read the raw data and understand it from all those different asset types, all those different instruments. Then being able to set up the plate layout, so perform the plate mapping, then really start the analysis. But even before considering, looking at the final result, obviously you need to be able to perform normalization, QC, iterate on that, have some validation loops. So doing both performing calculation and also visualization of your data. Once you're confident with your data and with the quality, you can obviously move on, perform sample analysis. Once again, it's about defining how you will aggregate the data, how you will produce the final results you're interested in, and finally being able to publish the final results, which the rest of your organization and your colleague will be able to trust, access, analyze, and make further decision on that. One key element in BIOVIA Assay is that the same tool will be able to address, I would say, the kind of two situations where you're thinking about analyzing assay data. One is about designing the analysis workflow, and the next one is about executing in a routine manner that same workflow. So let's take an example, designing a dose response run. So you will have spent a lot of time already, thinking about the instruments, how you want to measure that. Here we have an example where the dose response is actually coming out from an HTS run. So as an assay designer, I want to prepare the dose response template. So how I will perform every single step of the analysis. So choosing the plate reader, how I understand the instruments, doing the plate mapping, the step of normalization in QC, I think are the most appropriate for that type of assay. Same for sample analyzing, and finally publishing. What are the kind of visualization also that my users, my colleagues, will need to be able to make assessments on the quality and then on the sample analysis itself. So as a designer, I will be able to create, modify visualization templates in Assay. I will be able to choose from a library of readers, computation, and so on. Use that for the assay development on real data, and then be able to provide that, to make that available, to share that workflow with my colleagues that will use it for standard execution of the process. So now on the other side of the barrier, what about executing a dose response run? So as a screener, I want to be able to analyze, for example, an HTS run very easily using the best practices that has been defined by during the assay development process, and do that in a reproducible manner. So in the BIOVIA assay world, if I may say so, it's just about selecting a template, providing the raw data, and so proceeding through each step as designed, and finally publishing the results. So here, for example, I would just have to run my data through my plate reader, which would be a nuclear translocation image reader, for example, that will turn images into actionable data. Move that after plate mapping, on which I will also perform some multiparametric normalizations. Move to QC, where I will standardize my percent inhibitions, compute plate Z factors, or Z score per plate. Once the QC performed, assisted by some visualizations, I will be able to move to sample analysis after having mapped my samples from my inventory, compute the IC50 with the algorithm that suits me, and finally publishing, which is great because you just show that every single run is processed in the same way. All those steps are recorded, so you can go back onto the process and understand how the data is produced. It's very reproducible. It already minimizes a lot of errors. However, what if this was all happening automatically? Because at the end of the day, I'm providing the raw data. The process is almost always the same. Yes, there might be some visual inspections, but maybe there is a way for me to automate that. And if everything was going well, I shouldn't even have to look at the data. Of course, if something goes wrong, well, maybe this is something I won't look at. But let's imagine that you can produce the same results almost automatically. Well, this is exactly what Assay Autopilot is about. So it's about automating the full analysis of your plate-based assay using advanced analytics. And at this point, I want to invite Thomas to join the scene and give us some example on what does it mean exactly, how Autopilot changed the situation I just presented to you, and make the life of plate data analyst easier. Thomas?
Hello. Yes, so I'm going to talk about some, well, a very specific use case I have encountered in my work with a customer using BIOVIA assay to analyze, doing a screening campaign on 3 times 352 compounds. So 3 runs of 352 compounds using BIOVIA assay. Once we had designed the assay analysis, as Guillaume explained, this customer has used the execution mode to streamline the process and make sure that everything was analyzed the same way. But at the 2 steps that Guillaume mentioned, where the human intervention is somehow crucial, or at least that we need to have a quality control. The first one, assessing the quality of the control wells, was okay because it was quite simple. But when the customer reached the phase where he had to analyze manually and visualize the curves manually, basically it took him 3 hours to look at each curve and have a look at the outlier points and validate them and try to improve the fitting. So we have seen together how Autopilot could address some of these limitations, let's say, because 10 hours looking at curves, it's probably not the best use of a scientist's time. So what we did was using this template for the analysis, we used it in Autopilot. And the only thing that we had to do was to produce the raw data. So we had cases where the images were analyzed using Problem Pilot's imaging collection, but also sometimes the images were already processed in a third party software. And basically what we did was give Assay the raw data, the template, and wait for the report. And Assay Autopilot is not just automating the clicks on the button. It actually comes with a set of new functionalities that we have added that makes running an assay analysis automatically with confidence, trusting the analysis. And you can see in the orange boxes that at the QC steps, we have added the possibility to automatically invalidate control wells, for example. So in our case, we have used a pretty standard and easy invalidation based on the Z-score of the control wells. If your Z-score is lower than -2 or higher than 2, well, the well is invalidated and all the normalizations are recalculated, and all of this automatically. So Autopilot needed this functionality, this automated control quality in order to be possible. And for the sample analysis, so how could we replace the manual looking at each curve? Well, it was just looking into the literature, and we have implemented a a method, root. So it's based on a robust dose fitting, and it automatically detects and invalidates outlier points. So once again, we have implemented it in Assay, both in the framework, being able to automatically invalidate assay results based on some criteria, but we also provided some out-of-the-box analysis, including this root method that helps you invalidating outlier points on a curve. And finally, because also when you're not in the application looking and doing yourself the analysis, it was important for the customer and the customers that we have that we had discussed with to be notified that the analysis is finished, because going away while the analysis is running, you would not know when it ends. So we have, once again, as part of the autopilot feature, we have added a notifying system, which is fairly simple. You receive a report via email. And thanks to this, this report contains the information about how the analysis went, where things went wrong or things went well, and we're going to see or to talk about it afterwards. But this report can be quite customized, so that you have directly in the report the places to look at, maybe manually, to have a human eye on some points that have been invalidated automatically, but that you might want to have a look at still. Also, I have talked about it already a bit with the root method, but once again, Assay is a toolbox, so you can make it do whatever you want, but it's also important that some content comes with it. So we have added some new augmented analytics, and I didn't add this slide right after the first poll that we had. So we have feedback from our customers that indeed the assay complexity is rising. So thanks to these kind of new analytics based on literature, so based on state-of-the-art methods, we have added some new methods to accommodate for assay and plate bias. We have seen the root methods for dose response. You can use an unsupervised outlier detection for when you're doing hit selection. So basically trying to find what results is an outlier, and because it's an outlier compared to the rest of the assays, it might be it might mean that it's that it's a hit. And still the autopilot functionality, the autopilot feature, can benefit from the existing quite, let's say, classical analysis. So the Z prime normalization, the signal to noise, in order to normalize your data and make it easier to trust the automated analysis of your data. So in the end, in the test that we did with this customer doing the 3 times 352 compounds dose response, we went from a let's say 10 hours analysis for the 3 runs to 15 minutes automatic analysis. And once again, we're going to see it to discuss a bit about it with Guillaume later on, but it doesn't mean, because the analysis and the invalidation of the outlier points has been done automatically, doesn't mean that you haven't you don't have the possibility or the control to go back and, if you want, spend another 1, 2, 3 hours on each curve. But at least the work has been prepared for you before, thanks to Autopilot. Something that I will just mention without showing a bit, because it's the autopilot feature is also something that is quite interesting in environments where you require as less input from the user as possible. And especially when you have sensitive analysis, autopilot actually gives a way to easily set up assay analysis that will be automated and that will require few, if not zero, human intervention.
Well, thank you, Thomas. It's actually taking me to you know the first point where I wanted some highlight on that. So are we talking really just no human intervention at all, or just simply simplifying some of the most painful tasks of the process? Where is the balance there, and what does that bring exactly?
So it all comes down to the use cases. Autopilot will not be a feature that will be applicable to every assay, nor should it be. The thing is, for a bit like the Boston Dynamics robot here, some tasks like taking boxes and putting them from one shelf to another can be automated and have absolutely no human intervention. But for some operations in a storage warehouse like this, especially the ones that require very precise handling with the fingers or well, these things, robots are not yet good enough to do this. And if you do this parallel with assay analysis, some routine assay analysis, or some assays that are quite well understood and that are used in routine could be automated with no human intervention. Also, something that is also good with Assay Autopilot. So Assay Autopilot is the possibility to have a completely automated analysis of your assay. But the functionalities that I discussed that comes with this Autopilot feature, like automatic control quality, automatic invalidation of sample result, automatic selection of sample results, report at the end, they can actually be used in the classical or the design and execution mode. So if you want to have a hybrid assay analysis in BIOVIA Assay, you can, meaning that you can, when you are in design mode and you're doing some assay, low throughput assay that is very specific to that, you know, you need to change everything at each run. Still, you know that for the controls where the Z-score is higher or lower than -2, well, I want to invalidate them. Well, you can have a hybrid analysis of your assay. In design mode, you can use the automatic invalidation that gives you a first and automatic invalidation, and you can continue invalidating or modifying the data as before, and you will have a trace of which well have been invalidated automatically, which well have been invalidated or revalidated manually by whom. So in the end, Autopilot gives you the possibility to have no human intervention, or to have less human intervention in some cases where the complete automation is not required or desired.
Okay, good. That's actually raises another point. You mentioned reporting. You mentioned the ability that there is things you want to be in control. But one thing that people want definitely to avoid is to be in front of some black box system. So what in terms of reporting, knowing about what's going on, what happens if something goes wrong in the assay, if the results are completely out of scope, or if, you know, how are those things handled with Autopilot?
So Autopilot is just helping you automating the analysis in Assay, but it doesn't mean that you cannot go back to the data. So Assay Autopilot is not a black box. Given that you have the privilege, because there's also, in the idea of staying in control and in Assay Autopilot, you might actually want some users not to be able to go against the automated analysis. As I said, the case where you want no human intervention. But if you have enough privilege, and you choose who has what privilege, you can actually go back to the analysis as if it had been done in the application, and you can go back and look at the data at every step, and all the functionalities that already exist in Assay, meaning that correcting, so reverting the analysis to a certain step, correcting some things, and redo the rest of the analysis. All of this is still available in Autopilot. It's you keep in control of your data, and you can still copy your run in order to if you want to reanalyze it using other parameters, etc. So all the functionalities that are there in Assay before Autopilot are still there even with an Autopilot run. And the good thing is, as I mentioned, you keep a trace of who somehow went against the machine. And in terms of knowing if something went wrong and where, because you didn't go in every step of the analysis visually in the application, the report at the end that can be sent to you via email can contain this information. So the basic report that is provided with Assay actually gives you an idea of where the quality control invalidated some wells, so that you have an idea of where physically in the plates you had an issue, and what was the automated cutoff that invalidated the well, etc. So you already have a basic information on what went wrong. And the good thing is that, and we're going to talk about it, I guess, in the next slide, this reporting can be adapted to your need. So if you have, in some cases, for example, the HCS run that I mentioned, if you want to have attached to the report the images of the wells that were flagged as invalid or problematic by the automated analysis, you could add them to this report and make it very easy to have a clear and direct view on what went wrong in the Assay right in your mailbox.
Yeah, that's indeed actually brings me to the next point. Not only about how you can change your report, but you also mentioned analysis that your team has been including, new method analytics, previous one that were available for a long time. But what if I want to bring my own way of looking at data because my assay is different, it's special, or I just want to add some new cutting edge analytics in the system that has not yet been implemented in Assay?
So basically, we didn't. Well, you have said it, and I have said it. We didn't create a black box with an automatic analysis. It's actually using what Assay does since the start, which is providing you some analysis that out of the box, and the most common ones, and we add new ones at each release. But if you have your own way of doing the control quality, well, you can make it available in Assay. Same for visualization, same for reporting. So all the things that we like in Assay, you know, that we can make it our own and not blocked by basically the people developing it. You can actually take ownership of the analysis of the, and this includes the new functionalities that we have added. So you can add your own automatic invalidation at the quality control step. You can add your own quality automatic invalidation of sample results. You can add your own automatic selection of hits at the sample sample results, and you can create your own reports that will be created at the end of each run. And once again, I'm repeating myself, but it's very important. These functionalities, so the being able to add your own automatic invalidations, reportings, etc., they won't be only available when you run, when you do a completely automated analysis. You can use them in the way you have been using Assay before. So if you're doing a low throughput assay, you will be able to create a customized report for you that will contain the information that you want and make it available to all your colleagues thanks to the Assay templates.
Thanks, Thomas. One last point I like to hear from you about that I kind of teased in the first part of the discussion was about machine learning. There's no secret for anyone, I think, here that machine learning and AI are big hot topics. But now is autopilot helping in any way? How can you use machine learning in that context? Can you comment on that?
Sure. So out of the box, there is no fancy machine learning or AI normalization, automatic invalidation, etc. Because we haven't seen this kind of request that is yet mature enough to be somehow generalized. But when you think about it, with what I have just said, you can actually do it. So if you have a homemade cutting edge normalization based on machine learning, nothing prevents you from making it available in Assay. Something that is a bit more relevant, in my opinion, to the machine learning and AI topic is the AI machine learning. In order to make it work, or to make it work more easily, you need data that you can trust, data that is clean, and data that you can somehow compare. Autopilot actually gives you this kind of clean and trustable data, because you removed potentially all human bias, because you are sure that all your data has been analyzed the same way, controlled the same way, selected the same way, analyzed the same way. All the data that comes out of Assay Autopilot is a very good fuel for all your machine learning and AI data algorithm that you can build on top of these biological results. So in my opinion, this is a bit more relevant, how Autopilot goes in this topic of machine learning and AI. It's also something that that we are working on, but in terms of access of the data, interoperability of the system, being able to integrate Assay with other systems, being able to reuse all your data. Most of the way we do and we analyze data in Assay actually comes in the FAIR framework that is getting some traction recently too. So maybe Assay may not be at the core of the machine learning AI field, but it definitely integrates and goes along with it.
Thanks, Thomas. So, well, I hope you start getting convinced that automation, almost full automation is a possibility for you. And so here comes the next question for you, which is basically, how far are you ready to go on this? Michael, if you want to roll out the next poll.
Great. Yep, we've got that on the screen now. The question is for the audience, what kind of plate data analytics do you feel ready to automate? And your options are endpoint screening, dose response screening, high content screening, or all of the above. And so I'm sharing the results here. We have 8% responding endpoint screening, 38% responding dose response screening, 15% selected high content screening, and 38% selected all of the above. Guillaume, do you have any thoughts on that?
Well, first of all, that's pretty encouraging. I realize I haven't offered the options to say no, but nevertheless, it's interesting to see that even for the most complex assay, I mean, at least the one on the list, there is already quite an encouraging trend to go in that direction. So just to conclude on this, well, what do we think that Autopilot is bringing to plate data analytics? Well, obviously all of the above. It's really about being able to keep up with that amount of data, new and legacy. Legacy was something we didn't mention. It also takes a new sense with Autopilot, because, well, if your analytics, if the way for you to analyze a certain type of assay is evolving over time, what Autopilot also for you potentially is the ability to reanalyze those data and have a new and fresh look at those former results, making sure you can continue to be able to compare them with the newest one you're producing. So that's another nice additional value. Reducing the error, because we're reducing human intervention, but also because that Autopilot facilitates the promotion of best practices, standardizing the data. Well, obviously because of the reproducible way of analyzing them, which also bring those nice potential benefits when it comes to machine learning and AI, as mentioned by Thomas. And finally, getting more time focusing on science and business, which is probably the most important one. The example of moving from 10 hours to 15 minutes mainly means to me that it's more time for people to spend on the science rather than just looking at the curves, even if it's some kind of science, but it's maybe not the best part of the job. So with that, just a short word. Assay Autopilot is available today in the newest release by BIOVIA Assay 2020. It's also available in BIOVIA Science Cloud with Assay and or a lot of other applications. We talked a lot about Assay. We didn't go that much into details. We really wanted to focus on this new exciting topic for us of automation and namely Autopilot. We have a follow-up seminar next week. I encourage everyone to join, because hopefully you see that you're starting the potential in Assay. So in that next session we'll go into more details on Assay and also its companion application, Sample for Assay, which is about plate management. So just feel free to register for that next session next week at the same time. With that, we can open the floor to questions.
Very good. So I can go ahead and kick this off. The first question, how can I include my own normalization and calculations?
Yeah, so Thomas has been quite insistent saying, you can bring your own science, your own stuff and so on. The most I would say, natural way for to do that in Assay is by using pipeline pilot, which is fully integrated in Assay and is the easiest way for you to integrate any code, either based on some BIOVIA pipeline pilot capabilities, or based on other software, Python, R, or others that are natively integrated within pipeline pilot. So pipeline pilot is the easiest medium for you to bring in those new capabilities into Assay and make them easily available to all your scientists for their plate data analysis.
Great. The next question, can I reanalyze my data if my data processing workflow evolves over time?
Yeah, so I quickly mentioned that. One important point that Thomas made in the discussion is that all the executions, either through Autopilot or in Assay, is recorded and reversible. So that's one thing. But more easily with Autopilot, it would be very easy to just derive a new version of your template, of your workflow, of your analysis workflow, and run them again on all your historical data. So you could even potentially think about, maintaining the historical data in the same state-of-the-art of analysis than the newest one, if relevant.
Great. And what about plate management? Can we apply the same autopilot approach?
Well, I let Thomas talk about that. We didn't talk that much today on plate management. We'll talk about it more next week within the next webinar. There is a natural companion to Assay called Sample, also co-developed with Discngine. Thomas, what is your thinking about autopilot in Sample? Any customer example or?
So first, it would be, I don't know if you're sharing your screen with a link to the webinar. That would be good to share it. And while you're fixing this, I can indeed discuss this approach for Sample. So when you think about automating the assay analysis, a lot of the work in the lab in order to do biological assays actually comes before analyzing the results. You have to prepare your plate, and this preparation can be done manually, but it can also be done robotically. And Sample helps you both designing designing the work that needs to be done in order to prepare your plates, but also to automate it in some way. So this is actually something that is being considered as a future feature of Sample. So how to make Sample do the whole plate preparation, including the integration with the liquid handlers automated.
Thanks, Thomas.
Did I answer your question, Guillaume?
Well, that wasn't my question, so hopefully that answered the question of the
yes,
attendees.
sorry.
But yeah,
did I answer the question, Guillaume?
But you managed to answer what I wasn't able to. Yeah.
Beautiful. We have another question come in. Data analysis is critical, but before this step, there are other critical steps such as plate-based request. How is the request made at plate level? How is the request visualized? And how does BIOVIA establish the link from the plate all the way to pre-labeled tubes?
You want to take that one, Thomas? Again, it will be about Sample.
Yeah, it's once again about Sample. So part of the answer is Sample. Sample helps you keeping track of your inventory, preparing the plates, and this information that is that is generated in Sample is readily available to Assay. So when you think about a run, analyzing a run in Assay, you need two types of data. You need the raw data, and we have talked about it already. but you also need sample data. So what do I have in which position of which plate? And this information can be supplied by sample out of the box. So part of the answer is, well, this kind of information is handled in sample for Assay, the companion app of BIOVIA Assay. And a second part of the answer is the out-of-the-box integration between sample and Assay. So Assay is available to retrieve this information out of the box from sample. And I will add one last thing, that this integration between sample and Assay is not exclusive. You can actually retrieve data, so sample data, or all the data that has been mentioned in the question. All this data can come from other sources than sample.
Yeah, that's actually one of the points of configuration in Assay at the sample analysis step, how to perform the sample mapping. So this is one of the parameters you set up in your template, that rather coming from sample or through some of the sources. Low level one, like I will provide a file, but most likely it's coming from another system, and that will provide the information to explain to Assay where the sample are coming from, what is exactly in the wells.
Excellent. And it looks like the final question that we have received: how are invalidated samples managed? Is there a list generated which shows what needs to be retested in the analytics?
The short answer is yes. All those decisions are captured and can be reviewed. Now, how to address them is, I mean, how, yeah. I don't know about some out-of-the-box workflow to do that. Is that something that would be possible to, Thomas?
Yes. Well, I have the same answer than you. The short answer is yes. The slightly longer answer is that it depends on what you want to do and how and where you want to notify this. Thing is, the data is accessible and is somehow reusable. So in the report or in the notifying of the results of the analysis, the list of samples that have been automatically invalidated, that have been marked as invalid, can be extracted and sent wherever you want.
Yeah, I mean, it's true that something we may have made clearer maybe, that what we call a report at the end is, yeah, obviously it's a nice file that displays everything that happened in the run and that shows to the user, you know, the important points of the analysis. But overall, it's you can see it as a final step in the process. And so what you're doing with that information, putting it in a file and sending it by email, or sending it to some other collector of this information for further processing, is really an open question on which you have full power of decisions on what to do in those kind of situation.
Great. So it looks like this is all the questions that we've received. Thank you so much, Thomas and Guillaume, for sharing your time and expertise today. It's clear that the audience found this information very useful and interesting. Thank you so much for joining, and we look forward to seeing you next week at the next webinar.